In this lesson, you will learn about the components used to control, limit and maintain the pressure in an aircraft's hydraulic system. The normal operating pressure of the hydraulic system in a large modern aircraft is 3,000 pounds per square inch, psi. Smaller aircraft may have systems operating at 1,500 psi. Maximum system pressure is set and adjusted by the spring in the control piston for a constant pressure variable volume pump. Whilst in a system using a constant delivery fixed volume pump, this function is carried out by the automatic cutout valve, or ACOV. A number of other components are used to maintain or limit fluid pressure in various parts of a hydraulic system. Relief valves are used to relieve excess pressure caused by thermal expansion, thermal relief, or by failure of the normal system pressure control device, full flow relief. In the flap system, they are used for mechanical overload protection, flap relief. All act in a similar manner, relieving the excess pressure by returning fluid back to the reservoir. Thermal relief valves are usually fitted in lines isolated by non-return valves or selectors. The fluid trapped in these lines will attempt to expand if the temperature increases. This will cause an increase in pressure. If the pressure rises to approximately 10% higher than normal system pressure, then it will overcome the spring, pushing the ball off its seat. This will open a small orifice, allowing a small amount of fluid to flow back to return, thus relieving the pressure, allowing the valve to close again. In some systems, a full flow relief valve or high pressure relief valve is fitted downstream of the pump to bypass full pump output to the reservoir in the event of failure of the normal pump control system. A pressure maintaining valve or priority valve isolates secondary services from the pressure supply if system pressure falls below a predetermined value, thus giving priority to the operation of the primary services. Prior to system startup, with no pressure in the system, the spring will hold the pressure maintaining valve on its seat, cutting off the fluid supply to the secondary services. When normal operating pressure is available, the pressure acting on the bottom of the valve will be sufficient to push it up against the spring, allowing fluid to flow to the secondary services. The valve will now monitor system pressure. If pressure should fall, either because of high demand or a system fault, the spring will overcome the hydraulic pressure on the bottom of the valve, pushing it down, closing off the supply to the secondary services, giving priority to the primary services, until the pressure returns to normal. In aircraft with a single hydraulic system, a subsystem for the operation of the powered primary flying controls is often fed through a pressure maintaining valve, with the flying controls having priority over other services. The subsystem may also have a separate accumulator and a backup pump, such as a ram air turbine. Most modern aircraft will have multiple hydraulic supplies available for flight controls. 2, 3, or even 4 independent hydraulic systems can simultaneously supply power for the primary flying controls. On the Boeing 747, for instance, each primary flying control is split into 2 separate parts, and each part is fed by 2 hydraulic systems, so a pressure maintaining valve is not required. A pressure reducing valve is often used to reduce main system pressure to a value suitable for operation of a service such as the wheel brakes. Prior to system startup, the spring will hold the valve fully down, opening fully both the high pressure inlet port and the reduced pressure outlet. As system pressure rises, it will be felt on the valve base, pushing it upwards against the spring until the correct reduced pressure is reached. At this point, the inlet port will be fully closed. The valve will now modulate about this position to maintain the correct reduced pressure. If, because of back pressure, the reduced pressure should become excessive, then the valve will be pushed further upwards, opening the return port, bleeding off the excess pressure. A brake control valve, or metering valve, is essentially a variable pressure reducing valve, which controls pressure in the brake system according to the position of the pilot's brake pedals or auto brake selections as required. When the pilot is not pushing on the brake pedal, system pressure on the bottom of the valve will push it up against the spring, closing off the fluid supply to the brakes. When the pilot applies the brakes, he pushes down on the spring, increasing its force, pushing down the piston and allowing fluid to flow to the brakes. The pressure in the brake line will be proportional to the force applied by the pilot. In this lesson, you have learned that the normal hydraulic system operating pressure for a large airliner is 3000 psi, while the systems on smaller aircraft may operate at 1500 psi. We have restated that in a system using a constant delivery fixed volume pump, the pressure is controlled by the automatic cutout valve, and that in a constant pressure variable volume system, the pressure is controlled by the pump itself. You should know that thermal relief valves allow for the thermal expansion of trapped fluid. You have seen that a high-pressure relief valve is often fitted to limit system pressure should the normal control system fail. You have also seen that a pressure-maintaining valve, or priority valve, isolates secondary services from the pressure supply if system pressure falls below a predetermined value, thus giving priority to the operation of the primary services. And that a pressure-reducing valve is often used to reduce main system pressure to a value suitable for operation of a service that requires a lower pressure.